So our next function looks surprisingly simple. F of x is tangent of x. That's all it is. Nothing more complicated than that. And we go from negative pi over 6 up to pi over 3. So we're revolving this function around the x-axis and we're integrating over those boundaries. And so let's just set it up as we usually would. The volume would be the integral over these guys, negative pi over 6 up to pi over 3. Pi times f of x squared is going to be tangent squared of x dx. So I just square the function, pi f of x squared dx. That's what I'm going to try to do. So the question you have to ask yourself is, how do you integrate tangent squared? And we don't really have a table or anything we've really learned to know what the integral of tangent squared is. So your first cut, what I'm going to do here is take you down a road that you might go down initially, okay, and show you how you hit a dead end and how you have to backtrack and go. So what I'm going to show you now is sort of an aside a little bit. And I think it's important, because sometimes you don't know what substitution to make. And it's important to see how that can happen. So bear with me here. We'll make this part fast. What I can do is rewrite this tangent as sine squared over cosine squared. Because I don't know how to integrate tangent squared, I'm just thinking to myself, well, let me split it up. Maybe there's something I can do there. And so I get excited because I know that I can probably make a substitution here. U is equal to cosine of x. And if I do that, du dx, derivative of cosine is negative sine of x. And I get excited here because now I know that the dx is going to be the negative 1 over sine of x du. And the reason I say I'm getting excited is because I know I have a sign on the top that I think I'm going to be able to cancel. So I go ahead and finish the integration by saying integral negative pi over 6 up to pi over 3. I'm going to have pi. Then I'm going to have sine squared of x over, here I have cosine squared, but I have u here, so it's going to be u squared. And then dx I've defined to be this guy, which is negative 1 over sine of x du. And I'm like, rock on. This is great, because now I have sine canceling, but here I have sine squared. I have two signs up here. Well, I'll just cancel one of them. Let me rewrite the integral and just sort of simplify it here. So volume, I'm getting prepared to solve everything. Pi can come out of the integral, negative pi over 6 up to pi over 3. And what I'll have here is sine of x over u squared du. So negative sine, and I have a negative sign here, so I'll just put a negative right there. Negative sine of x over u squared du. So I look at this and I'm like, well, certainly I'm on the right track. I did the cancellation, everything seems to work. But what I have is, I have u squared, which I know how to integrate, but sine of x didn't go away. Okay, it didn't go away because whenever I chose my u, it didn't totally cancel. And in fact, I chose u is equal to cosine x. If you choose u is equal to cosine squared x, you're going to have the same problem. When you take the derivative of cosine squared, you're going to have the same problem. So you're not going to be able to get rid of it, right? So that's kind of a dead end, at least one dead end that you might run into when you solve this problem. And you kind of stare at this for a while and you start thinking, well, how can I play with this and get it all in terms of u? But it's tricky because these are trigonometric functions, so I can't, sometimes when you have x's up here, you can back substitute from your substitution and get u's, but since they're trig functions, you can't do that. So you do this, and sometimes you just hit a dead end. I'm not saying there's not a way to solve it in a similar manner. I'm not going to go out that far. But I'm saying that your